Alright, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna carry on learning about Godot. And well, we are probably gonna look into making something, not something big, just like a simple scene that I want to set up, a simple hello world kind of scene. But before that, I need to finish learning about signals. I'm still on this part where I'm learning about what signals are and how to use signals. I finished learning how to use input, and that was pretty interesting. Because not only did we learn how to use, well, in this case it wasn't we. I didn't do that on stream. Uh, in fact, I think even create your first script. Yeah, I think I did both of these off stream. I did create your first script and listening to player input, both of them off stream. In fact, I just finished this section, I think, I don't know, an hour or two ago. And then in between, I went to cook something to eat, and then I was relaxing for some time, and then I started up the stream. So, after I'm done with this section, which is using signals, then I want to start exploring on my own. I don't think I'm going to be following these sections too much. I mean, I might like go through them and get some points here and there. This is the actual like contents. Um, I might go through them and like get, you know, some points here and there and try and understand stuff. I don't know if I'm gonna go through the entire thing. There's also a 3D section. I should be looking into both of these, but I kind of wanna explore on my own, if that makes sense. Just do stuff by myself instead of following strictly with a tutorial. Up to this point, step by step, this section has been super helpful for me. So I'm still trying to understand the difference between 2D and 3D here. The 2D and 3D workspace, because the objects in both of them, they seem to be in like two different places. So I'm kind of having a hard time understanding exactly how that logic works. Because like as an example, let me create a second. Can I have two root nodes, or do I have to have? Okay, hold on. I'll create a 3D. Okay, let's just create a blank 3D node, and let's make it a child of the sprite 2D node. Now that's in the 3 that shows up in the 3D workspace, right? It automatically switches to the 3D workspace. Another thing to notice is the units, the coordinates, or yeah, I guess the units, basically the position. The position here is in what I'm assuming might be meters. I'm not sure, but it's 3D coordinates, right? It's not in pixels. On the other hand, if you look at Sprite 2D, which is in the 2D workspace, that's being shown. The position there is being shown in pixels. So I'm kind of having a hard time. Connecting the two. I don't even know if I'm supposed to be connecting the two, because like what I'm used to in Unity is, okay, you have one 3D scene. In that 3D scene, even if you create screen space UI, even that has like that has like a separate section which shows up in the 3D scene, and because it's screen space UI, so like no matter where you place that canvas, it's gonna be like on the screen. And then you can move UI elements around in it, right? Any if you look at the 2D side, if you create a sprite, that also usually has a 3D position. But if what makes a difference there is the camera that you are using, the camera perspective that you're using. Because if you are using an orthographic camera, that's what they use for 2D usually. Then the X and Y is gonna be taken into account, but I think Z is not. I don't remember exactly, but I think Z is not taken into account. I think so. I think no. I think Z is taken into account because like to determine which one is front and back. But my point is, all of that takes place in the 3D scene. Like you can still see it in the 3D scene, right? Here, when I click on a 2D object, a 2D node, it shows it to me in the 2D workspace, but I cannot view this in the 3D workspace. Let me try hitting F to like focus. No, that doesn't work. If I deselect the thing and select it again it goes back to the 2D space. So I need to understand the connection between the 2D and 3D workspace. Give me a second. I need to hydrate. I didn't hydrate before starting the stream. Because here's the thing, right? I know. Just a second. Is my voice coming through? Yeah, okay. So here's the thing. I know that the object or the node, I'm going to keep calling it an object because I'm not used to the Godot terminology just yet. But I'm going to have to keep correcting myself is what I mean. So this sprite node, it is within these bounds. I'm not sure if this line is if it's visible well enough on stream, but if you look at my mouse cursor, there's like a blue line here. And it sort of denotes what the camera can see. That's what I've gotten so far. So like, for example, if I, let's say I move this object here, it should show up as only half on like in the build, right? Let me test that out. You guys probably won't be able to see that because it pops up in a new window and that's not captured by OBS, but I can tell you if that happens. Yeah, I'm right. So this is sort of the camera bounds, right? That's what I've understood so far. Shit, you know what? I think I might need to go through this section, your first 2D game. I kind of want to explore on my own, though. I don't know. I don't know. I kind of want to explore on my own. I've got this itch that I just want to explore on my own. I don't want to limit myself to the tutorial. Like we've done enough of the step-by-step, and I know some of the basics now, enough to be able to do a few things. And based on that, I want to start building more things and learn in that way. So I don't know if I'm gonna. Maybe I could jump to the manual. What's the? Because like at this point, I think I can start looking at the manual and see which sections I need specifically, like which sections I need knowledge about specifically. Okay. Wait. Is there a Sprite 3D I just got this random thought. Is there a Sprite 3D component? No, that's under 2D. Oh, there's a Sprite 3D. All right, let's make a Sprite 3D component. And now that shows up in, oh, lost it. There it is. That shows up in 3D. There it is. Man, I'm loving this selection mode thing with these shortcuts that we have. It is so convenient. I don't have to click anything. I just have to hold the Alt key to orbit and hold the Control key to zoom in and out, and then hold the Shift key to sort of pan. And of course, F is to, focus. But yeah, okay, so this is a Sprite 3D object. Alright, so this means if we want to make 3D objects, we create 3D nodes, right? Any 3D node is going to show up only in the 3D workspace. But where in this scene, this is what I'm trying to understand, right? Where in this 3D space is the 2D side of things located? Like, where exactly is that happening? Or could it be that the engine is handling it in a different way? Like, maybe the engine is just, it's actually, no, yeah. Where in this 3D space is this stuff located? Because, like, if we are able to see it here, right, shouldn't we be seeing it somewhere, like, not shouldn't we be seeing, actually, yeah, shouldn't we be seeing it somewhere? If it's here, if it's in this space, doesn't that mean that it is also located in 3D space? Or I just realized that my VTuber avatar is obstructing the view, so I'm gonna fix that real quick. Actually, maybe I could put it down here, because you guys don't need to see the resources, but like you might need to see the node trees. So I think this should be good. Just a second, let me just finalize this and we're good. Okay, so yeah, like I was saying, if I don't remember like exactly where I left off, but like I'll back to what I was saying here, that if it is located here, doesn't that technically mean it is located somewhere in 3D space? Like, why are we forced to look at it from this view? Also, okay, so another thing to take into account is we have the x-axis and the y-axis. So we are not looking at it like a top-down view. It's like a front view, right? So x would be pointing in, actually, I can't say for sure if x is pointing in, or if forward is pointing in, plus or in minus, because I remember reading somewhere that Godot's coordinate system is like a little different. I need to look into. Oh, you know what? Let me look that up right now. Godot coordinate system. Introduction to 3D, 2D coordinate systems and transforms. That extra Z coordinate makes many of the common techniques that helped to make 2D games simpler no longer work. Okay. Oh, okay. To aid in this transition, it is worth mentioning that Godot uses similar APIs for 2D and 3D. Most nodes are the same and are present in both 2D and 3D versions. In fact, it is worth checking the 3D platformer tutorial or the 3D kinematic character tutorials, which are almost identical to the 2D counterparts. Okay, fine, great. I'm trying to understand. Hold on. We can test this out right now. So if we are looking at this in the global, if we are looking at it from like the global axes, uh, okay. So let's say we are looking at it like this, and then let's look at the positions, how they change. So that goes in negative, and then that goes in positive. So positive is forward. Negative. Oh, wait. Okay, so this is one of the differences here, right? Negative. So this is what I guess this would be called the right-handed coordinate system, because positive y is in the left direction, not in the right direction. Yeah, positive x. Did I say positive y? I don't know. I don't know if I said positive y. Okay. Anyways, positive x is in the left direction, not in the right direction. Whereas if you look at unity, it's in the right direction. Y, on the other hand, is positive up, negative down, and Z is also. Oh, let's hide that. That's convenient. Z is also positive forward, negative backwards. So this is something I'm going to need to get used to in Godot's. Well, in Godot in general. I was about to say in Godot's coordinate system, but like just in general in Godot, this is something I'm gonna need to get used to. Which, I mean, it's not that big. It's not that big of a deal. It's just like once you get a hang of it, then you can use that in your calculations. Why was I doing this? I forgot. I think I think I was trying to figure out the coordinate system. So yeah, I think this would be considered a right-handed coordinate system, right? Because like if you hold up your right hand and you make like the XYZ thing with your thumb, index finger, and middle finger, then your thumb is pointing in the left direction, meaning X positive would be pointing in the left direction. But if you do like a right-handed coordinate system, X positive is pointing in the right direction. Let me just confirm that I'm giving the right information here, because I'm saying what makes sense to me. I don't know if it might be wrong. Hold on. Left-handed coordinate system. Okay. Alright, typically 3D graphics applications use two types of Cartesian coordinate systems, left-handed and right-handed. In both coordinate systems, the positive x-axis points to the right. Okay. Hold on.
اندمج فيما يعجبك مع يوتيوب بريميوم. شاهد الفيديوهات بدون إعلانات وبالإنترنت ومع إمكانية تشغيلها في الخلفية. جرب يوتيوب بريميوم مجاناً.
Okay. For right-handed coordinates, if the thumb of a person's right hand points along the z-axis, all right, in the positive direction, then the fingers curl from the positive x-axis. From the positive x-axis towards the positive y-axis. Okay, all right. Okay, that's an interesting way to look at it. Because like what I've learned about is the thing where you make, you know, the three of your fingers are pointing in like different directions, and each of them represents a different axis. All right, when viewed from a position along the positive z-axis, the 1/4 turn from the positive x-axis to the positive y-axis is counterclockwise. Okay, yeah, that makes sense. Okay. For left-handed coordinates, the above description is the exact same, except using the left hand, and the 1/4 turn is clockwise. Okay, okay, so now I'm even more confused about like, hold on, hold on, hold on, dude. Okay, I'm reading this on another screen, by the way. So like you might not be able to, like, if you're not seeing anything in the little browser window that I have in the top right, then that's why. Okay, typically 3D graphics applications use two types of Cartesian coordinate systems, left-handed and right-handed. In both coordinate systems, the positive x-axis points to the right. Okay. And the positive y-axis wait, hold up. So is it like this? Points to the... Okay. Alright. So if I'm looking at it from this angle, that means z is flipped here. So z positive goes backwards. Like I guess it here it matters like what angle, which axis I'm looking at it from. Previously I was looking at it from this axis, right? So I was like, oh, okay, x goes in this direction, x positive goes in this direction, and negative goes in that direction. But like if you look at it in the other way, like this, x pointing in the right direction, then you would say that z is flipped here, right? Okay, let's carry on reading. Okay, so what I'm seeing here is in left-handed versus right-handed Cartesian coordinates, the only thing that's different is where z points, apparently, based on what I'm reading here. Hold on. In both coordinate systems, the positive x-axis points to the right and the positive y-axis points up. You can remember which direction the positive z points by pointing the fingers of either your left and right hand in the positive x direction and curling them up into the positive y direction. Okay, so positive x direction, curl it up into the positive y. Okay. On the other hand, if I want to do it like this with the right hand, you guys can't see it. I'm doing it IRL. I'm trying to. Okay, so with my left hand, if I make sure that the fingers are pointing in the positive x direction, and then I curl them up so that the, y is pointing up, then z is pointing forwards, which is the left-handed coordinate system. On the other hand, if I try to do the exact same thing with my right hand, making sure x is still pointing to the right and y is still pointing up, then z would be pointing backwards. That being said, okay, let's carry on reading this. The direction your thumb points, either towards or away from you, is the direction that the positive z-axis points for that coordinate system. Okay, so we can test that out here. Positive z points in the backwards direction. That means Godot uses the left-handed coordinate system. Let me just Google that. Also, I think I missed a hydration break. Give me a second. I didn't hydrate very well after having my dinner, so that was a mistake. Okay. Godot left or right coordinate system. Godot uses a right-handed coordinate system. Okay, that means z points in the reverse direction, like in z points backwards. Let's read. Hold on. Okay, the y coordinate is used for up. As for horizontal x and z axes, Godot uses a right-handed coordinate system. This means that most objects that need alignment, such as lights or cameras, this means that for most objects that need alignment, such as lights or cameras, the z-axis is used as a pointing towards direction. This convention roughly means that x is sides, y is up and down, z is front and back. Oh man, I love that they have used Freya's Freya. I don't know how her how the other name is pronounced, but like I'm just gonna say Freya. So Freya, who is like amazing with shaders and stuff, she made Shader Forge, and she made a couple of other things, and a couple of years ago, I think, something that she released was a plugin called Shapes, and actually I don't remember if it was a couple of years ago or if it was like in the last year or two. But yeah, she made Shapes as well. She made a couple other things as well. And she also she streams on Twitch. You can go check out her channel. She goes by Ace Gikmo. ACEGIKMO. Anyways, Freya had made this chart, which, okay, now that I'm looking at it on another screen, I think I should bring it up here. Let's look at where exactly am I here? 3D, introduction to 3D. So I'm going to open up a new thing here. I don't think I need to open up a new thing. I think I'm already in 3D, right? No, I'm in 2D. Okay, and then introduction to 3D. This. Freya had made this chart. You can even see her sign there. So this was kind of how I'd gotten my idea of which, okay, you know what? Okay, I had the wrong idea of how exactly these fingers are supposed to be pointing, but like this does represent pretty much the same thing that the other method is teaching you of like determining how to, you know, figure out left and right hand coordinates. So let's test this out. So the idea here is you take three fingers, right? Let's say on your left hand, right? The idea is that you always point X to the right and Y upwards, right? And then wherever Z is pointing, which if you're using your left hand, then the middle finger is pointing right and index finger is pointing up. What remains is your thumb, and that's pointing backwards. No. Did I hold on. No, wait. Doesn't right-handed points backwards? Yes. Okay. Hold on, there's an ad playing. Okay. I just remembered. I was getting this whole thing confused. So, looking at this diagram, again, keeping in mind that X and Y, previously when I described what I thought was going to be the left-handed coordinate system, my calculations were wrong because I was trying to point the thumb towards Z. That was wrong. So, with your left hand, you try to point your thumb to X in you know the right direction, and your index finger to Y in the upwards direction, and then the middle finger where it's pointing, that's your Z. So that's in the left-handed coordinate system. Then it would become, you know, forward Z, and then with the right-handed coordinate system, you do the exact same thing. Thumb is X, index finger Y, and then the middle finger is pointing backwards. Right? So let me just, yeah, okay. Godot uses a right-handed coordinate system. I just made a huge confusion, a huge mess out of this, out of whatever I learned previously, because I forgot the whole how you determine coordinate systems and all that shit. I don't use this left hand, right hand terminology usually. So I confused the whole thing. But yeah, okay. Glad that's cleared up and glad that I figured out how to determine the thing. I'm pretty sure I'm going to forget it again. In a couple of months, I'm going to make a mess out of it again. But that's just how it be sometimes. Now, that being said, wait, what is this Y up and Z up thing? Okay, so I didn't look at this. So Z up, it's a Blender thing, right? Yeah, Blender does it as well, and of course a bunch of others as well. So this is kind of interesting. Many people wonder why in some applications Z points upwards. To me, also, it didn't make sense. But like to be fair, my introduction to game dev was with Unity, and so my mind connected all coordinate systems to that. And then later on, I started exploring, Blender and a bunch of other programs that have different coordinate systems. In this one time, I was in a VR chat hangout with a bunch of other people, and they were discussing like coordinate systems, right? And they were like, people complain about Z pointing upwards, but to me, me as in I'm whoever I'm mimicking whoever was talking. So to that person, basically, that person was saying to me, Z pointing upwards makes sense because if you think about it, when we learned about um, like graphs in school, we didn't usually look into the z-axis. There was usually just an x and x and y were on a horizontal plane. It was They didn't really consider it vertical, even though like we wrote it on paper like in a vertical way. But this was that person's understanding, and when I looked at it from that point of view, it kind of made sense to me. They were like, okay, if you think about it from that point of view, that yeah, x and y are on a horizontal plane, then to add the third dimension, z would need to point upwards. And yeah, it kind of made sense. I was like, yeah, sure. I still don't get, like, I kind of get it, but I also don't get it. It just kind of made sense that yeah, okay, that's a decent enough reason. I don't know what the real reason is. To be honest, I'm not really that interested in finding out what the real reason is. It just is what it is. Different programs use different coordinate systems. So I knew about the Y up and Z up difference, but like left-handed versus right-handed, this is something that doesn't often come up for me. The only time that I had to worry about this was when I was working with shaders. Um, as in once I got into shaders, that's when I learned that some graphics standards point Z forward and some point Z backwards. That's when I had to worry about like, oh shit, okay, what, it might be a little different because that affects the calculations that you're doing. Where Z points exactly, it affects the graphics calculations. Though that being said, I didn't have to worry too much about it because like as soon as I learned that yeah, different APIs use like different directions, I also learned that Unity kind of handles that for us. Um, but at the same time, they also give you constants that you can read to figure out if, because like if you are doing some custom graphics work, some custom effects, and you are doing the calculations manually, you're not necessarily using their matrices and stuff like that, then you might need to write two blocks of code, one for if it is pointing forward and one for if it is pointing backwards. I forgot exactly what the constant is called, but the Unity does have one. I think it's called Z reversed or something like that. Anyways, okay. So I was trying to figure out the difference between 2D and 3D. Um, I'm okay. I'm curious. I want to Google this. Why can I not see? Okay, so 2D object in 3D scene. Project 2D scenes onto 3D objects. Um, Combine 2D and 3D in one scene. Some people here are trying to show 3D models in a 2D world, which is, yeah, I haven't tried that out yet. So we can be here and let's say I added, well, yeah, okay, I added a node 3D, right? And then that goes into the 3D scene. Okay, let's see what this person is saying. Because, like, I'm wondering if Godot kind of forces or um, enforces this thing where 2D or what? I was about to say 2D objects again. Node 2D nodes can only show up in the 2D workspace, and node 3D nodes can only show up in the 3D workspace. I'm wondering if it does like that kind of enforcement. But like what if you wanted to mix up 2D and 3D then? I need to figure out the connection between 2D and 3D in Godot. I also need to understand cuz like it's still kind of like a mystery to me that okay, if it's a 2D object, we can only see it in the 2D workspace, but for whatever reason, we cannot see it in the 3D workspace. Like that just doesn't, I don't know, my mind is not able to connect the dots there. Yeah, I need to read up on this more to get a better idea of what's going on. Anyways, we can carry on with signals. I need to, I'll do the research on 2D versus 3D later on. Maybe I can ask somebody on Twitter to explain it to me. Or if somebody sees my VOD on YouTube and they want to share some information, then, I would appreciate that. Somebody actually did comment on one of my previous Godot VODs, and they answered some of the questions that I had. Like I'll randomly throw out questions as I'm talking throughout the stream, right? So like I'll throw out questions and I won't even remember what I asked. But throughout that stream, there were a couple of questions. One of the question, I think they answered 3 of the questions, or maybe 4 of the questions. They were also nice enough to, let me know that uh, the audio cut out in some of the areas. The reason why that happened, I let them know as well. The reason why that happened was some of the machine supremacy tracks that I used, they were not copyright free, or well, not safe for stream. So as soon as I ended the stream, Twitch's content ID picked it up and it muted. There were three tracks in total, so those small segments got muted, and I didn't want to fight it. I just let it go. Just a second. What's going on here? Give me a second. Oh, it was here. So this was the video. Um, they were nice enough to explain the difference between a scene and a T scene or a text scene. Apparently, the difference is that one of them is it's text, it's in text form, so it's human readable, and they were also clarifying this thing about. I was wondering that since you can edit themes for UI in the engine, I was wondering if that same theme could be applied to the editor itself. And based on what they said, apparently it can be applied. But if you're just trying to change colors, there is an option for that as well. You don't need to do the whole theme thing. If you're just trying to change colors, which to be honest, that's all I was interested in, it was changing colors. Apparently, there are options for that, so I can look into that. Also, they let me know that my my pronunciation of Juan was right, because I was saying that I wasn't sure if it was pronounced Juan the Spanish way or Juan as in some other language. So yeah, Thank you for that. But yeah, why did I bring that? Oh yeah, because I was talking about somebody answering my question. Okay, so I need to understand 2D versus 3D. I feel like there needs to be like a page, or there might be a page. I just need to find the page that explains the difference between 2D and 3D workspace. I'm gonna Google this real quick. Godot 2D versus 3D workspace. Okay, so there is an introduction to the editor. I believe that's here. Introduction to Godot's editor. Wait a second. Okay, so we can try exploring this a little bit. Is workspaces part of this section or some other section? This is editor introduction using the web editor, advanced features. Okay, cool. Wait, there's a command line? Oh yeah, there was a command palette that I'd seen. I haven't looked into that yet. But I have seen like the option for some kind of command palette. I haven't. I assumed it might have been like a command palette like what VS Code has. But once again, I haven't tried it out, so I don't know exactly what it is. But let's see here. Command line tutorial. Some developers like using the command line extensively. Godot is designed to be friendly to them. So here are the steps for working entirely from the command line. Given the engine relies on almost no external libraries, initialization times are pretty fast, making it suitable for this workflow. Dude, speaking of it being fast, let me just say, so I haven't done a whole lot of complex stuff yet in Godot. I'll get there eventually. But whatever I've done so far, it's been pretty fast. Even building, even entering play mode or running the scene, I think they call it in Godot. I'm not sure what the terminology is exactly, but basically, yeah, testing out your scene, running your scene makes more sense, right? Rather than saying entering play mode, because like Godot doesn't necessarily look at it in that way. Um, Though no, it does. It does, doesn't it? Because like I mean, it doesn't call it play mode, but like it would be considered play mode. I think it would be considered play mode, right? Also, I don't know if I mentioned this or if I even tested this out on stream during any of the previous streams, but dude, you can make changes and the changes actually persist. It doesn't like go back to where it was. Actually, wait, no. No. No, no, no. You can make I said that wrong. You can make changes to objects in the scene, like in the editor. Those changes they persist after you exit the build. Now I don't know how well that works out when you are actually like moving objects around, but something that I did try out was, so I'll enter play mode, or well, you know what I mean. I'll enter play mode. I just keep saying it. And then I'll move this object. Oh, wait, I'm setting it. I'm doing some stuff from script. Forgot about that. Yep, I forgot about that. So I'm gonna close the current build and uh okay. So we'll return from this function. Init doesn't matter. Okay, great. So now I should be able to run the thing. Okay, so I can move this here. Wait, I think I'm confusing myself as to what I can and cannot remember. Like what I did test out was, okay, so this was one thing. Like you can make the change in the editor and it shows up in the build. That's good, right? But then what about when you exit? Oh yeah, okay, so that change persists. That's what I was trying to remember. Now I get it. So changes that you make in the editor, this is, I think this is what I was trying to remember. Changes that you make in the editor, they show up in the build, but at the same time they also persist once you exit play mode. Once you close the build. I think that's what I was trying to get at. I don't even remember what I was trying to mention. Anyways, dude, let's fucking I haven't moved forward with this thing. Let's do the signals thing. Holy shit, dude. Okay. Here I was expecting to not go off on a tangent and to actually get some, you know, studying done. Which to be fair, we did get some studying done. We learned some other stuff. We didn't we didn't necessarily learn what we were supposed to learn here. Give me a second, let me hydrate and then we can carry on reading. Okay. In this, hold on. I'm curious. So I'm going to Google this. Cannot see 2D nodes in 3D scene. 2D scene in 3D scene. Okay. Any way to stop showing 2D or 3D on add/create node? The reality is that Godot doesn't work that way. It's not a 2D or 3D engine. It is both at the same. Oh, this is interesting. Okay. Wait, no, this is from back in 2016. I don't know to what extent that might still apply. Can you make a 2D game into a 3D into go into the 3D space and back? Okay. Why can't I see a node after? Nope, that's not what I'm looking for. Why don't I have a 3D viewer? Okay, 2D on 3D HUD viewport. Okay. So I'm reading a Reddit post from 2 years ago. 2D node, 2D nodes in 3D screen. Hold on. What happens if, okay, so let's delete these two nodes. Okay, and then let's save this sprite. Actually, I think I have a sprite saved here, don't I? What was it called? I think it's just called Sprite 2D. Oh yeah, I do have it saved. Right, so let's make a 3D scene. In this 3D scene, we have the node 3D, and let's drag and drop our Sprite 2D as a child node. Okay, I didn't mean to do that. What did I just do? Oh, I dragged and dropped the script. Where is the thing? Oh, there. Sprite 2D. That's what I was trying to add. Right. So this shows up here. Where is it showing up here? Okay. Uh, yeah, I'm still confused about this. Okay, let's carry on reading. 2D scene and 3D scene. There are ways for this. Setting the display of the main node along with a full background. Going to another two-dimensional scene and returning to the three-dimensional scene using the changes of scene to file. Using the change of scene to file. Using two cameras. Considering that there is a camera in the 3D scene, it is possible to create another camera. Speaking of cameras, dude, what happens if I try to run this scene? Let's, for the sake of showing something, let's add, I don't know, is there like a box? Uh, what about some kind of mesh? Mesh shape that uses the mesh resource. Okay, let's try that. Do they have preset meshes for us? Box mesh. Hell yeah. Let's go. Let's add a standard material to it. Great. Awesome. Now, if I run this, I haven't placed a camera in the scene, right? What happens exactly? Let's call this some 3D scene. Okay. It's still displaying. It's still displaying the 2D thing. Do I need to add a camera to this? So let's do camera 3D and let's move the camera back. Actually, how do the controls work for selection mode in 3D? Click and control drag is to rotate. Alt right mouse button is to show a list of okay. Control drag. Oh, okay, that's to rotate. All right. Okay, whatever. We can bring this back here. I don't know if all right. So I'm not sure if I'm just trying to make sure that the camera is able to see almost the whole thing. All right. Okay. Uh, does the camera have like a what do you call it? Like a what is that called? Like a priority kind of thing? Am I able to set something like that? Do I need to set something like that? That's the more important question. Okay. Yeah, that's not helping. But that's kind of weird because like why is it showing me this scene? Or why is it showing me the 2D scene when oh, is it hold on. Play the edited scene. Isn't that this scene? What if I close this? Nope. Still same thing. All right. What happens if I delete this? Okay, that's interesting. Okay, you know what? I think I'm gonna have to go through these two sections as well to get a better idea because otherwise it's gonna be a bit frustrating trying to figure out the various things. Yeah, I think we are better off going through. Though it's hold on, there's some information that I'm missing here. Any way to stop showing 2D or 3D on add create node? Okay. All right. So why is whatever this camera is seeing, why is that not showing up? Do I need a light of some sort? Cuz like I mean, I'm seeing it here. Okay, let's drop a light in here. I don't know if cuz like I'm seeing it in the scene, right? I'm seeing the skybox in the scene. I don't know if it exists in the play mode. I don't know if the camera is seeing it. Like I don't know if there might be some issue like that. Do we have a point light? Yeah, that is a 2D node. That is not what I meant to do. Okay, wait, what is this? Okay. Uh, okay, let's just look for light. What all do we have here? Is omni light, omnidirectional light? Isn't that the same as yeah, such as a light bulb or a candle? Okay, so that's our point light basically. Okay, let's move it here and here. Now let's enter. I just remembered you guys can't see what I'm doing. Okay, so that worked. So basically, what I'm seeing here, we see a skybox here. That skybox is not being, it's not seen by the camera. I think that might have something to do with this environment thing. what if okay, so let's hide this. And now let's try running it. Did that work? No, that didn't work. Oh, what if I place the camera on the other side? Well, I mean, okay, so the point light, it solved the issue here. We can bring it up. Yeah, there it is. So there is the cube. You guys can't see it once again. You can't see it because the new window opens up. A new window opens up to show the build, but that's not captured by OBS. So, you know, just take my word for it. Now, that being said, why is it that when I drop a 2D scene, let's say this in here, why is it that when I drop that, it takes precedence over... No, it does not. Hold on. Okay. Okay, so you guys cannot see... You know what? Okay, I'm gonna show it. Let's just turn on display capture temporarily. So you guys should be able to see this now. Let me close this. Let me also go back to the script and comment out this return. And now let's go into this. There you go. Look at that, dude. Wait, can you see it? Hold on. You still cannot see it. What? It's because I did not transition. Wow. Yeah. Let's restart that. So this is the build. And this is our 2D sprite, our 2D, sprite. And behind that is the cube, which now it's visible after I added the Omni light. So we have both the 2D and the 3D thing going on here. So does this mean that 2D objects cannot exist in 3D space? Is that a thing? Like, is that how I'm supposed to make sense out of this? That 2D objects, they don't really exist in 3D space, but like Godot shows both 2D and 3D space at the same time, with 2D just being overlaid on top of 3D. Is that how it works? Because like when you work with UI, if I remember right, you have to work with UI in the 2D the 2D workspace as well. I need to check out if they have any world space UI kind of thing. I'm not sure. Give me a second. Let me hydrate. Actually, I need to do a couple of things. So give me a couple of seconds. Okay. So let's carry on. So I'm gonna exit. Wow, my voice, holy shit. I'm gonna exit play mode. I'm gonna exit the build. I'm not sure how to say that. And I'm also gonna close display capture so we can carry on seeing the rest of the stuff. I just remembered I wasn't sure if I was supposed to stream today. I knew I wanted to stream. It's just that I ran so long yesterday, which, because of my voice. So, like, I wasn't sure if I wanted to stream today. Well, no, I wasn't sure if I should stream. I knew I wanted to stream, but like, I was wondering. And I remembered all of this only after, like, now, 1.5 hour into the stream. Now I'm remembering that I wasn't sure if I was supposed to stream today. Because, like, after doing a 4.5 hour thing yesterday, I was like, yeah, dude, I need to give my voice some rest. Maybe I shouldn't stream tomorrow. I guess I forgot because, like, dude, to be honest, since the time I woke up, I've just been doing Godot stuff. So my mind was kind of just preoccupied in that. Though, also, like, to be fair, I'm like, my voice is not doing that bad today. It's okay. I'm like 1 hour and 12 minutes into my stream. Just a second. I think YouTube. Yep, YouTube did their pausing thing. I have no idea how long the music has been paused, but I just played it again. Speaking of music, shout out to Machine Supremacy. I'm playing their music. Go check them out. They've got a lot of pretty amazing music. A lot of it inspired by video game music. So yeah, go check them out. Pretty good stuff. Now, before I spoke about the music, what was I talking about? I think I was talking about, like, yeah, 1 hour 12 minutes. I'm 1 hour and 12 minutes into my stream, and I mean, my voice is, it's still, it's doing okay. It's not really that bad. I'm, to be honest, not feeling too much stress on the vocal cords, and I was actually super happy about that. Even like yesterday, I was so happy about it that I made a tweet about it, or I posted on X, however we are supposed to say it. That's how happy I was about it. The fact that I was able to do a 4.5 hour stream with just, like, with my, every 15 minutes taking sips of water, and I was able to last for at least 4.5 hours, or even 4 hours. That was good. Granted, like, by, I guess, the 3 hour mark, it started to become stressful to talk, I think. But dude, even being able to get to 3 hours without feeling that stress, that's still good. That's still great. Okay, all that being said, let's get back to signals. I still need to experiment more with 2D and 3D to understand exactly what is going on. Also, um, what happens if I place this mesh here? Because I'm trying to understand if we start mixing 2D and 3D nodes, what exactly happens in terms of rendering? Like, how is the rendering for it handled? Let me try running this scene. Okay, so it shows up. You guys can't see it because I switched back to the, you know, the old layout. But like, yeah, the second cube does show up. So does the first cube, and so does the 2D node that was there. But here's the thing. In terms of editing the node, how do we make sense out of the fact that, okay, we click on the 2D node here, but then we click on the child node, which is here, and that shows up here. Doesn't the parent-child relationship make it so the child transform's position gets affected when you move? Isn't that how it's supposed to work, or is that not too much of an issue? Let's try doing something like this. Okay, let's move this here, and now let's move this entire thing. Yeah, so the 2D node moves, but it seems like the 3D node, it stays in place. So that's kind of confusing. I need to. This is why I need to figure out the way that 2D and 3D works. I need to do more research. I need to read up more on this. I think that the problem I'm running into is just that I'm doing my usual thing. This is how I explore and learn things. I'm just curious about how various things are. It's just that now I'm doing it on stream, but like I would even be doing this off stream. Like I would be curious that, hey, how does this work? How does that work? Why is this working this way and that is working that way? And then I would spend some time doing research on it and find the answer. So right now I just need to understand how 2D and 3D works. Also, what happens if I run this and I start moving the... Oh, wow, okay. I forgot that both of them have the script attached to them. Okay. Alright, dude. Enough messing around with this. Okay, I'm also gonna delete... Actually, I don't need to delete it. Yeah, we're gonna come back here and we are gonna go back to reading on... let me hydrate real quick and then we're gonna carry on reading about signals. Previously, off stream, I learned about scripting in Godot, and I also learned about listening for input. Let me just say, like a side thing, I love the fact that rotation in Godot, at least on the 2D side, I haven't looked at the 3D side yet, at least on the 2D side, the rotation is as simple as, hey, this is the angle in radians. That's it. Like that's all there is to it. There's no, oh, quaternion this, Euler angles that. And they've simplified things a lot, in the sense you can how do I put this? Just looking at their example. Let me show you here. Okay, so you look at this vector2.up. This represents the global up direction. And then there's the rotated method, which rotates the vector. It'll rotate it by whatever angle you want, right? The great thing is the angle can be provided by the rotation itself. Rotation in this case is the node's rotation. And it's a 2D node, so it's a 2D it's a 2D rotation. I don't know. I don't know in 3D. I mean, in 3D there has to be 3D rotation, right? That makes sense. But I haven't messed around with 3D just yet. We'll get into that. But this is I liked this a lot. Like you can rotate you can rotate a vector easily by just like specifying the angle to rotate, and even when you're referencing the rotation of the current node, even that is shown in as an angle in radians, so you can easily just pass that. Guys, give me a second. All right. So let's carry on reading. I don't remember what I don't remember if I was done talking about this. But yeah, I like how Godot has, and so far, keep in mind, so far I've only seen like the 2D side of things, but I like how they've simplified it to where it's just, oh no. Okay, fortunately, I didn't hit the wrong key. Okay, so yeah, I like how they've simplified it to the point where it's as simple as, okay, this is the rotation in these in this angle, and you can just use it. It is, I don't know how to explain it properly, but like on the Unity side of things, it would have been slightly more complicated to do that because the rotation is represented as a quaternion, and it's not that it would have been horribly complicated. It's just slightly more complicated. This is, or rather I should say, that is not complicated, but this is even simpler than that. That's what I really liked about it, because like in Unity you would have to deal with like the difference of, oh okay, it's represented as a quaternion, but like if you want to do something, if you want to work with angles and stuff, you have to convert those you have to convert the quaternion to Euler angles. They have methods, helper methods for that, but like just the fact that you have those two separate things, it kind of complicates things a little bit. And here it's just so much more clean. So I was that was just like, I don't know, it blew my mind. I was happy with that. Okay, getting back to this, we're gonna, dude, eventually we're gonna get to, reading this. Okay. Using signals. In this lesson, we will look at signals. They are messages that nodes emit. They are messages that nodes emit when something specific happens to them, like a button being pressed. So right now. I'm trying to look into collision detection. So I think signals might be what I'm looking for as well. Like maybe there's a signal that fires when a collision happens. On the Unity side, that would be, I'm looking for the equivalent of on collision enter. Other nodes can connect to that signal and call a function when the event occurs. Oh, speaking of other nodes, so another thing I want to look into is how to control multiple nodes from the same script. Something like, so far I kind of know a little bit about GD script and how the stuff works. I've understood that when you create a script and you attach the script to a node, the script inherits from the script itself is a class, and it inherits properties and methods from the node that it's a part of, and it's whatever those classes inherit from, it inherits all of those things. So that's why you have access to a bunch of properties and methods and stuff. Now I know that this goes like towards this is like, it inherits all the parents things, but what I'm trying to do here is from the parent I'm trying to control the child nodes, or I also want to try controlling nodes that are not in any way related to the node on which I have the script. So I want to see if that is possible, if that is good to do, or like if that could, basically I want to try doing that. I'm sure there's a way to go about doing that, and I want to find out how exactly. So this is where I have like a lot of experimenting to do, a lot of digging to do. So I need to start making, you know what? Okay, I need to start making dumb stuff in Godot, just so I can learn a bunch of shit. I think that's what I need to do. I need to follow my own philosophy, because this is what I say, this is what I tell beginners all the time, people who are beginners in in any field, in any tool that they're learning. If they're beginners and they're trying to get better at whatever it is, let's say it's a program, let's say it's Unity. If you're trying to learn Unity and get better at Unity, my advice would be keep working on projects. Make dumb stuff. Make anything, even if it's dumb, even if it's something that you don't plan on selling, or even if it's something you don't plan on ever showing anyone. If it's something incredibly dumb and silly, make it. Spend the time making it, because that's going to teach you something. At least that's how it has worked for me. I've been using Unity for a good decade, and like even to this day, every project that I work on, it teaches me something. It did an ad start. Oh, okay. I guess I'll be quiet for 30 seconds.
استمع إلى الأغاني الكورية باستمرار حتى
Oh,
عند استخدام تطبيقات
I should
أخرى.
hydrate.
احصل على يوتيوب ميوزك بريميوم.
All right, welcome back. So, yeah, okay. Keep my tangent aside. Let's carry on reading. Signals are a delegation mechanism built into Godot that allows one game object to react to a Oh, I paused for a second just to confirm that I read that right and I didn't accidentally read node as game object. It actually said game object. Okay. Allows one game object to react to a change in another without them referencing one another. Okay. So events, basically. Using signals limits coupling and keeps your code flexible. All right. For example, you might have a life bar on the screen that represents the player's health. When the player takes damage or uses a healing potion, you want the bar to reflect the change. To do so in Godot, you would use signals. As mentioned in the introduction, signals are Godot's version of the observer pattern. Okay, yeah. Basically events. We will now use a signal to make our Godot icon from the previous lesson move and stop by pressing a button. Oh, pressing a button on screen. Okay. Cool. So we are going into UI stuff now. Scene setup. To add... Dude, I'm wondering if I should actually go through with this. Like, go through this entire section as well, because I feel like this is going to introduce me to, like, a bunch of concepts that'll be super helpful. How big are each of these sections? Setting up the project. Okay, it's gonna ask me to download a bunch of assets. That's fine. Then creating the player's scene. Okay, so this is going into animation. All right. Oh, also node structure. Wait, it's not showing the node structure? To begin... Oh, okay, it's telling that you need to... Okay, all right, that's fine. Then coding the player. Okay, this is a slightly big one, I'm guessing because it has a bunch of things to explain. All right, then creating the enemy. Okay. The main game scene. You know what? I think this is gonna introduce me to a bunch of important concepts in Godot, and it might be in my best interest to go through all of these chapters. But you know what? Having said that, even as I'm saying that right now, I still can't help but think to myself that, dude, I kind of want to explore by myself. I, c- I don't know what it is, dude. I kind of want to explore by myself. I want to learn. I want to learn by doing research. Learn by exploring various things. So like they're telling me to, they're guiding us through this whole thing, right? But instead, I want to build things myself and learn based on that. Yeah, you know what? We're gonna do that. We're gonna do dumb shit in Godot. That's how we're gonna learn. All right. So, scene setup. To add a button to our game, we will create a new main scene, which will include both a button and a sprite 2D and the sprite 2D T scene. The sprite 2D scene, basically, we created earlier. Okay, create the new scene. All right, in the scene, do so and so. This will add a node 2D as our root. Okay. In the file system doc, click and drag sprite 2D. Okay. We want to add another node, so all right, we're gonna add another node, then button, and then we resize the button. Okay, all right. Toggle motion. Okay, so that's our button. Okay, so let's do all of that. So we create a new scene, add a 2D node, drag and drop sprite 2D, add a button. Give it a second. Okay, so that got added as, okay, so maybe I should do this instead. Is that, what's the hierarchy supposed to? Yeah, okay, it needs to look like that. Right, great. So let's just enlarge that and bring it here. So that's our button, and we need to add the text here. Toggle motion. Okay, great, done. Your scene tree and viewport should look like this. It does. Okay. Save your newly created scene as Node 2D scene if you haven't already. You can then run it with F6. At the moment, the button will be visible, but nothing will happen if you press it. Alright, cool. Let's try that. Okay, so we'll save the scene, run the scene, and yep, great, cool. Exit. I love how fast it is to enter play mode, do whatever you want, and then exit play mode, dude. Holy shit. This is so fast. This is, keeping in mind that so far I haven't made any complex scenes, but the reason I'm excited for this is because in Unity, even simple scenes, I would have to wait for a couple of seconds to enter play mode. So like, I don't know, this kind of stuff, this excites me. All right, so we are done with that. Connecting a signal in the editor. Here we want to connect the button's pressed signal to our sprite 2D, and we want to call a new function that will toggle its motion on and off. We need to have a script attached to the sprite 2D node, which we do from the previous lesson. Okay. You can connect signals in the node dock. Select the button node, and on the right side, okay, all right. The dock displays a list of signals available on the selected node. All right, let's check that out. So we select this, and then we go here. Okay, all right. Double click the pressed signal to open the node connection window. All right. What next? So you guys probably can't see the window because it's a separate window. But you can see in, this web page, it looks pretty much like this. There you can connect the signal to the sprite 2D node. The node needs a receiver method, a function that Godot will call when the button emits that signal. The editor generates one for you. By convention, we name these callback methods. We name these callback methods on node name signal here. No, on node name signal name. Oh, okay. All right. Here it'll be on button pressed. All right. Okay. Note, when connecting signals via the editor's node dock, you can use two modes. The simple one only allows you to connect to nodes that have a script attached to them and create a new callback function on them. The advanced view lets you connect to any node and any built-in function, add arguments to the callback, and set options. Wow, okay, that's convenient. That can actually be very useful for like more complex systems. You can toggle the mode in the Windows bottom right by clicking the advanced button. Okay. Click the connect button and complete the signal connection and jump to the script workspace. You should see the new method with the connection icon in the left margin. Oh, so I'm starting to see what they meant by GD script has deep editor integration, like it's very tightly integrated with the editor. Okay. So we click connect, moves over to the script window, and then we have this. Yep, I can see what they meant by there's like deep editor integration. I need to see what the integration looks like if I decide to do this from VS Code instead. I'm interested in seeing what that looks like. By the way, this is super convenient. The fact that you're able to hold down control and then you can click on, let's say, this function. This is it's a virtual function that you can implement this in one of your scripts, and these functions basically allow you to communicate with the engine. So in this case, this is a virtual function called process, which gets called on the node every frame. So it gets called, it updates the node every frame. And just like this, you have a bunch of other nodes as well. You have a bunch of other functions as well, like init and I think unhandled input, I think it's called. There's a bunch of them, and you can just control click anywhere in your code, and like you can read the the documentation for specific methods and properties and types and so on. That's convenient, dude. That is very convenient. Okay, let's go back to this. We were here. Okay. If you click on the icon, a window pops up and displays information about the connection. This feature is only available when connecting nodes in the editor. Okay, cool. Let's replace the line with the pass keyword with code that'll toggle the node's motion. Okay, so I'm guessing we need to make a global variable as well, like a class level variable that's then going to be used. I'm just guessing. Our sprite 2D moves thanks to the code in the process function. Godot provides a method to toggle processing on and off. Node.setProcess, another method of the node class. Wait, no, I didn't read that right. Godot provides a method to toggle processing on and off. The method is called setProcess or node.setProcess. Another method of the node class is processing returns true if idle processing is active. Okay, if idle processing is active. When we use the not keyword, man, what is going on with my reading? We can use the not keyword to invert the value. Okay. All right. Great. Cool. So basically, set process. Nope, not what I meant to do. Set process not is processing. All right. Great. This function will toggle processing. Oh, that's okay. So that's clever. So you can completely toggle processing on and off. You don't even have to like set a flag or something. So you can that way you can avoid having to unnecessarily call into that function. That is clever, dude. Okay, this function will toggle processing and in turn the icon's motion on and off upon pressing the button. Okay, before trying the game, we need to simplify our process method. Okay, our process function to move the node automatically to not wait for user input. Replace it with the following code. Yeah, okay, I don't need to do. Oh, this is the same code from the beginning. Yeah. You know what? Okay. Just for the sake of redoing it, I'll do it again. Okay, so we first wanted to set the rotation, right? Wait, what's going on? Oh. We first wanted to set the rotation. Rotation plus equals. What was it here? Hold on. Now I can do this. We had velocity. No, not velocity. We had the angle something. Angular speed multiplied by delta. Oh, okay. Yeah, that makes sense. Yeah, because we are adding to the. So this is another great thing, right? Okay, rotation it's a vector 2 from if I remember right. Hold on, let me hover over this thing. Or let me just click on it. Yeah. Vector 2 is rotation in, well, okay, it's rotation in radians, but like, isn't it? I thought rotation is a vector 2. But rotation, oh, is it because it's 2D rotation? That's why it's just one thing, and that's why it's in radian. That's why it's just one field. A rotation in radians relative to the node's parent. This property is edited in the inspector in degrees. If you want to use degrees in the script, use so-and-so. Okay. All right, cool. Yeah, I don't remember why, because I think I was confusing the rotation and the position uh, types. Because like rotation in 2D would usually only be around the y-axis. You don't usually rotate around the x or... Did I say y-axis? No. Rotation in 2D is usually only around the z-axis. You don't usually rotate around the x or the y-axis in 2D. Okay, so yeah. So rotation, it gives you the rotation in angles, in radians, right? It's simplified. It's a lot more simplified. I'm guessing if this was a 3D node, you might have rotation in 3D. And I guess even that is going to be in radians. I guess we'll find out once we get to 3D. Next, we need the velocity. So we create a variable for velocity. The velocity is vector2 dot up, and we want to rotate this by rotation. So this is great. Rotation is just the angle, right? It gives you the angle in radians, and that represents the rotation of that 2D node. And then you can use that in rotated. So this basically gives you the rotated version of vector2 dot up, and then we are multiplying that by... What were we multiplying that by? Was it by delta here or somewhere else? I can't remember. Oh, okay, I have it here, right? Oh, it's by speed. I have to multiply it by speed. Okay. And then position, which is a vector 2 plus equals velocity multiplied by delta. All right, great. So now we can run. Okay. Yep, there we go. Hell yeah. Okay. Your complete so-and-so should look like this. Okay, great, cool, awesome. Run the scene now and click the button to see. Okay, so this is important. Connecting a signal via code. You can connect signals via code instead of using the editor. This is necessary when you create nodes or instantiate scenes inside of a script. Yeah, it allows you to make things more dynamic. Let's use a different node here. Godot has a timer node, and a timer node that's useful to implement skill cooldown times. To implement skill cooldown times, weapon reloading, and more. Head back to the 2D workspace. You can either click 2D, click the 2D text at the top of the window, or press Control F1. Oh, so far I haven't done that actually. I haven't used shortcuts. I'd been meaning to look into shortcuts. Oh shit. Okay, cool. For a second there I panicked because I hit Control F1, F2, F3, and then F4, and suddenly I was like, oh, is it gonna close? Then I remember, oh no, that's Alt F4, so we're good. Okay, in the scene dock, right click on the Sprite 2D node and add a new child node. search for the timer, and add the corresponding node. Your scene should now look like this, okay? With the timer node selected, go to the inspector and enable the auto start property, okay? Click the script icon next to the Sprite 2D, next to Sprite 2D to jump back to the, okay, cool. We need to do two operations to connect the nodes via code. Get a reference to the timer from the Sprite 2D. All right. So I need to create a timer. That's convenient, by the way. They have a timer thing here. So then we go over to script, and in the script, I think at this point I can get rid of all of this code. So in the script, it says that we have access to the timer, right? What if, is that it? Like, no, this is the class timer itself, but like, is that referencing the child node timer? What if I rename this? Let's call it some timer. Yeah, no, not just yet. Okay, so that's a different way of doing it. All right, get a reference to the timer from the Sprite 2D and call the connect method on the timer's timeout signal. To connect to a signal via code, you need to call the connect method of the signal you want to listen to. In this case, we want to listen to the timer's timeout signal. We want to connect the signal. We want to connect the signal when the scene is instantiated. Oh, so it should be an init. And we can, wait, no, okay, no, I'm wrong. We can do that using ready, the built-in function, which is called automatically by the engine when a node is fully instantiated. To get a reference to a node relative to the current one, we use the method getNode. We can store the reference in a variable. All right, okay. So coming from Unity, I'm gonna need to check what is the performance. How does getNode affect performance? Because like I'm guessing they must have found a better way to implement it. Because I remember stuff like get component and get game object or game object.find, stuff like that. They would say that it wasn't the best for performance because it would have to like iterate over all of the objects in the scene or iterate over components and stuff. So it was always better to store a reference beforehand if you had the option to. Okay, so what should I name this? Timer equals, what is, oh, just get node. Okay, get node. Oh, cool. Okay, they're giving options here. Some timer, which is a child of the Sprite 2D node. I wonder if dot means the parent node, the current node itself. Okay, the function getNode looks at the Sprite 2D's children and gets nodes by their name. For example, if you have, I also like that it had the name right here. Like it had the name. I didn't have to guess the name. It was able to suggest names to me. Like, look at this. That is convenient. For example, if you renamed the timer node to blinking timer in the editor, you would have to change. Oh, see, that's not convenient, right? So I need to find a way to, yeah, I need to find a way to remedy this situation where if you are getting it by its name, then the name doesn't change if you rename the thing, which, to be fair, like, yeah, that's how even GameObject.find works. But like, if that's the situation, then it's probably better to store a reference to the node instead of finding by name. Okay, we can now connect the timer to the Sprite 2D. Is the music still going? YouTube likes to pause it every now and then. Yep, it paused it again.
YouTube and exclusive access to all things VIP. Try 1 month free of charge.
All right. We can now connect the timer to the Sprite 2D. We can now connect the timer to the Sprite 2D in the ready function. Okay, timer.timeout.connect on timer timeout. Oh, we need to create the on timer timeout function. Okay, this line reads like so. We connect the timer's timeout signal to the node to which the script is attached. Oh, okay. We connect it to the node to which the script is attached. When the timer emits timeout, we want to call the function so-and-so that we need to define. Let's add it to the bottom of our script. Okay. All right. Timer dot connect, I think. Yeah. Timer timeout. Oh yeah, I haven't defined the thing yet. Do I need to wait? How is it supposed to be specified? Signal string name. So do I have to do it like this? Timer timeout. Okay, and then let's create a function. Timer timeout. Okay, so now let's try to what am I doing wrong here? Oh, okay, so I have to specify it like this. Oh, hold up. The event, I'm supposed to get the event, right? Or the signal, not the event. I'm supposed to get the signal. That's not showing up here though. Timer.timeout.connect. Okay, I'm not seeing timeout. Why is it not? Wait, what am I doing wrong here? Okay, hold on. Let's not use IntelliSense for the time being. Are we good now? Oh, okay. I guess we're good. By convention, we need these callback methods in GDScript as we name these callback methods as so-and-so, and in C# as so-and-so. Here, it'll be on timer. All right, fine. For GDScript and on timer for so-and-so. Great, cool. So that's just convention. I'm assuming it's not meant to be strictly followed. What is visible? Oh, it just controls whether the thing is visible or not. So like show and hide. Visible equals what? Not visible. Okay. So we're just flipping it. The visible property is a boolean that controls the visibility of our node. The line visible, not visible toggles the value. If visible is true, it becomes false, and vice versa. Alright. If you run the scene now, you will see that the sprite blinks on and off at 1 second intervals. Okay, there was something else that I needed to do with the timer. I think there was some auto run thing. Auto start. There you go. That's what I had to do. I just remembered that. Okay, so I'm gonna run it. You guys probably won't be able to see it, but I'll tell you if it works. Alright, dude. Yeah, it seems to be working. The thing blinks. Alright, custom signals. Oh, did not mean to do that. Okay, alright, so I'm gonna get into this. But for the time being, I need to end the stream because I started the stream a little bit late. That's on me. But yeah, I need to end the stream. I will try to stream again tomorrow. Hopefully more Godot stuff. Or maybe back to doing the work on the VTubing app. We'll see. But yeah, that's going to be it for now. I hope you guys have a nice day. And I will see you all next time. Peace.